Okay, I will start now. Just 2-3 minutes. I just put charger on. Just a minute. Just what about the charger? I put charging also on. I think almost all problems are taken care now. See, that call disturbance, screen tilting, that is taken care. Sound problem taken care. Even laptop problem also taken care, I think. See how much I can go. So that I want only board, no outside disturbance. Okay, I'll go little down and up. Is the screen fully okay? Okay. Today, if it is clear, everything is solved now. All problems are solved most fully. I tried some trials and now everything is okay. Now only problem is the lag. Everything is okay. Voice also. Is the voice crystal clear? No. Voice also crystal clear? See, voice clarity is there. Laptop problem solved. Call problem solved. And other one is which one? Sound problem, almost all solved now. See, there is always a solution, but you should go for solution. See, one small thing, I think not possible today. I will put a cello tape all around so that I will restrict the board view. I will put it, not now, after the class today. So, in case when I write, I go out of the range. Inform me immediately, not visible. In case I go. Okay. We will start now. Ready for starting? Voice okay, everything okay. Ready for starting now? Remember now, powerful concepts are coming today. After this class, I will try to finish today only these concepts. Then, the more important portion, that overhanging beam and cantilever solve, we will take up one by one. Okay. But as much as possible, give reply fast. Do not delay. See, that lag problem I have to overcome. The only problem is a lag problem. That will be soon, as early as possible, I will remove the lag problem. I think some app you have to use. If you use an app for live streaming, then lag, I think is there. 0 something is there, tolerance. Now it is called mild. It takes around 10-15 seconds sometimes. Okay. Now, see. I told we are at present, we stop the problem there. We are discussing how to decide that variation curve. See, I already told you, if it is linear, nothing required. Why should I talk linear? So, I am concentrating only on higher power, x square or x cube. Now see, correctly, how to remember? Just for example, see, make a note. See, suppose there is a couple here acting, M, clockwise or anti-clockwise, M. We want a section XX here, A point here. Imagine one more standard point B is here, or B or C, okay. Okay, take B only. Don't buy out B is the right end. 2 points, A and B, standard points. Between them, take a section XX. I write one by one now. See, I forgot to note down the class number in the YouTube. I will let you know. Either in the break or next class I will let you know. So anyway, you can search it. What you can see, relation between SFD&BMD, and then you can see one complete, what the name I used there? Some full clarification given, all concept in one class, where I wrote no load, no shear force, no load with constant shear force, UDL, UVL, everything I written there. You go through, final summary is there, go through that one. Actually go through earlier also. That concept of SFBM, everything go through. And then even the pre-requirement class also very important. Start from class number 1. Go through everything. Come to class number 100. Then see the level. Okay, now see. Imagine there is a couple acting here. See, if the couple also is not there, then there is nothing to discuss. Why tell me? If nothing is there here, see, when you want SF or BM, you have to always look one side. We will look this side. That side you cannot see because it is a cut. Beam continues. Cut. Okay, therefore, see, if neither force nor couple, if none of them is there, it is idle. Like what? No SF, no BM. When there is no SF, no BM, who want to talk about it? Leave it. Now, suppose there is only a couple. I am giving extra information. Only a couple, M. It can be like this or it can be like that. Don't bother. Now, if I take a section here, see correctly, shear force at XX will be 0. And BM at section XX will be equal to plus M. No one should ask me, why plus? I will tell harshly, if you do not know that one, go back to class number 1, come to class number 100, then start from here. M. Okay, that means only M is constant. Okay. So when there is no shear force between two standard points, then first of all, SFD you don't have to talk. When there is nothing is there, what you will talk? So many people miss this one. They will tell when there is no load, they will tell shear force constant and BM linear. No, before that one thing comes. See, that is next one. When no shear force is there, shear force diagram is not there, and BM will be constant, so it will be a rectangle, or this is called constant BM for entire that region, or there is a name called pure bending is there. These all I discussed earlier. Okay, take. Now, this is first case. Second case, imagine there is a force of VA here. Then shear force equal to plus VA. Why plus VA? I don't know. Bending moment equal to plus MA plus VA into X. That is X power 1 will come here. So between two standard points, if there is no load is there, then if shear force exists, shear force is constant. It will be rectangle. And BM variation is linear. Linear means straight line. See here MA, then it will keep on increasing to some other value. Okay. Therefore, here also nobody got difficulty. Why? Linear. Why trouble? You mark the ordinate, but do not mark nonsense. Why nonsense means what? I told you. Mark 3 meter, then mark here 5 meter. If you mark this way, it gives nonsense shape. That you have to avoid. Not that you hold 3 meter here, see, and take a scale, etc. See, 3 and 5, you want to mark 3. Okay, 5 over. Or suppose 10 and 2. 10, 2, 5, 2. Okay, 10 and 2. If you maintain that much scale, shape will come correctly. Okay. Therefore, even now, when there is no load between 2 points, we have nothing to discuss about variation curve. So, over. This all you can see there. Start. Case 3. There is UDL between the two standard points. Anybody can tell? Someone asked me earlier, sir, between two standard points, you told when there is no shear force. Okay, clear, sir. Then you told shear force is there, no load, shear force is there, no load, then shear force constant, BM linear, correct. Next you suddenly jump to when there is a UDL is there between two standard points, say W per unit length. U means unit length, don't write U. It is not a value, I have shortcut. See, in the YouTube class, I wrote always per unit length because I have seen people, they will imagine U is a value. Okay, unit length. Then someone asked me long back, you have not covered the case, so you told no shear force, no load, one case. Okay, no shear force, pure bending. Then shear force is there, no load, and then shear force constant, BM linear, clear, sir. Next you suddenly jump to UDL. Then what is your problem? Sir, you have not covered the case. If between two standard points, if point load is there, what to do? Tell the answer. Complete nonsense question. Tell why. I will tell complete nonsense question. If between two standard points or salient points, if point load is there, then why I am not discussing? I will tell him, first you get the case. So what, sir? Sir, there is a point load here. Again nonsense. Tell why. Tell why. Reason. This question important. Why nonsense it is? Telling that between two standard points, if a point load is there, sir, why you are not covering that one? I have to laugh and leave it. Reason. Why? Laugh is ಕನ್ನಡದಲ್ಲಿ ಹತಾಶೆ. ಅಯ್ಯೋ ಈ ಥರ ಕೇಸು ಇದೆಯೋ ಅಂತ. ಹಿಂದಿಲಿ ऐसा भी होता है. English, such people also there. Reason. Anybody can tell? Reason. Between two standard points, if a point load is there, then why you are not discussing it? Complete nonsense. Tell why. I told you earlier somewhere. In my regular class I told, and also I told in YouTube class. Laughing actually. Anybody can tell the answer? Fast. See, sometime little communication required. Now today laptop is working. So laptop working, you can comment. Tell why. Lag problem I will remove earliest possible now. Some app I have to use, then lag problem is gone. Once the lag problem goes, you have to give answer immediately, like you used to give in my Zoom class. Why? See, this much lag is not there, I am sure. Why? Reason. You are not answering. If you don't know, tell don't know. I told already. Whenever I ask a question, if you do not know, tell don't know. I am there, tell it. If you do not know the answer, tell don't know. But should not keep quiet. Should not make me keep on waiting for the answer like that. Oh, I should go for, screen is 144 is there. You should go for advanced quality. I will go to 480. If I go to 480, it is crystal clear. Don't know, no. Ayyo, what is this? 1 minute. What is this? What don't know? See, what is standard point? Tell me. Or salient point. What is that one? Where beam starts, where beam ends. Extreme ends. Where supports are there. Where there is a point load or couples are there. Or where there is what? Where UDL starts or UDL ends. Or where UVL starts or UVL ends. They are called standard points. If there is a standard point load is there in between, see, suppose for example, see, VA, M, A and B. Someone will tell, if a point load is here, then this also will become standard point. This will, then your section should be here and here. See, between two standard points, see, first of all, where point load is there is a standard point. Like between two official bus stop, two successive official bus stop, if another stop is there means what I can tell? It can be only a request stop. It cannot be official bus stop. If it is official bus stop, then that will become official. Now clear? So that doubt comes to the mind. Now clear or not? Between two standard points, if point load comes, first of all, question itself is nonsense. Because then that point also will become standard point. Then they will tell, oh, okay sir, yes, correct. So therefore, when you discuss the variation, after second case over, third case is when there is UDL between the 2 points. See now. Now remember. You should remember one thing now. See, I'll write here, lastly I will write once and then once for all remove it. In future, I will not tell. There's a limit for explaining. See, UDL and UVL. Now only I will tell you. See, shear force UDL means like this. UVL is, it can be like this, or it can be like this, or it can be like this. Anyway, section is in between. Section is in between. Then, for shear force and BM. Visible there? Board visible? Oh, I went it up. Board visible, I think. Okay. Now see, if you should know now once for all. Don't remember by crude method. If UDL is there, shear force is x power 1. BM is x power 2. If UVL is there, shear force is x square, UVL is x, bending moment is x cube. Means linear parabola of sufficient. Parabola or quadratic, second degree. This also parabola of second degree and parabola of third degree. Already told you so many times in the YouTube, I proved it. Now, how to remember? See, UDL to UVL, always when you come down, power increases. This way also power increases. This way also power increases. UDL, shear force is linear. BM, now you have to remember. Further I can't tell. If a UDL is there, shear force variation linear, BM, second degree parabola. If UVL is there, shear force is second degree parabola, BM is third degree parabola. I will tell you how to remember. Confusion means, see, for me I don't require it. When you write equation for shear force, see, at x from here, intensity of load is constant. So we want total load. Total load will be only in terms of x. See, intensity into x will give total load. So x will come only once. Therefore linear. When you do bending moment, intensity of load into x is the total load into x by 2. Oh, x square will come. Come to UVL. If you come to UVL, your intensity itself will be in terms of x. In terms of x. when you take a section XX in between, your intensity itself will be what? In terms of X. Intensity varies. That also see, simple language. Intensity varies means when linear variation is there, anywhere it is X power 1. Now, when you do shear force, see, area required. Area means what? X into X will come. Half is not required. Half into base into height, half leave it. X into X will come. So shear force quadratic, bending moment, area X base into height X square into a part of X, either X by 3 or 2X by 3 or A plus 2B, etc., etc. There power becomes one more X will come, X cube. Fully clear? This here, see, I don't require these things all. In the mind should come. UDL, last I am telling, I am rubbing everything now. UDL, shear force linear, BM, second degree parabola. UVL, shear force, second degree parabola, BM, third degree parabola. Fully clear? Okay, son. Now I will not tell these things. Over. Because if I tell further, you should log out and tell your class we do not want. Why? What you think of us? You should tell that way. What? You think you know everything, we don't know anything. We also know. This much is sufficient. Okay. Now, last part I told, very important. See, this is the important of curvature, where difficulty is there. So many people make mistake. And if you make a mistake, it looks sometimes very ugly. See now. UDL, forget it now. Now you know when linear and when parabolic. Now, if linear, I don't have to talk. But one thing important, see, this also, I will write once, explain and stop. See, I told you last time, still once again writing. Rate of change. See, this is called teaching instinct. Told so many times, repeat and telling. Why? If anybody is new, let him understand. Rate of change of shear force is intensity of load. And remember, rate of change of shear force means dV by dx. After this time, I am not explaining. I will not talk about this one. So you should tell already, you should comment. Sir, drop it. Already over. Leave it. Let me also learn. Okay? Let me also learn. So rate of change in mathematics means differentiation. dV by dx. And you know that dV by dx is W, that is intensity. And second one is rate of, second is the first point. Second point, rate of change of bending moment is shear force, V. Rate of change of bending moment means dm by dx. dm by dx equal to shear force V. And again I told you, last class told 100 times. When you write dV by dx or dm by dx, mathematically dy by dx is slope. Slope for the curve y equal to f of x. Therefore, I am telling last time now, dV by dx is slope of rate of change of shear force, that is slope of shearing force diagram, and dm by dx is slope of bending moment diagram. Remember now, last I will tell, if you want to decide what is slope of shear force diagram, see what? See load diagram. See loading diagram. If you want to decide the slope for shearing force diagram, earlier diagram, loading diagram, and slope equal to intensity of load. Now remember, right, if it is UDL, slope intensity is constant. Means slope is constant. Correct. Why? If it is UDL, I'll write here. See, if it is UDL, it is a straight line. So straight line, wherever you mark the slope, slope is constant. So, and if it is uniformly varying load, then intensity varies linearly. Therefore, slope also will vary. Slope also will vary. If it is UDL, slope will be constant, straight line. If it is UVL, parabola will come. Slope will vary. How vary? Where intensity is less, slope is lesser. Where intensity is more, these all you write, slope is more. If you go from lesser intensity to higher intensity, if you move that way, slope keeps on increases. Whereas if you move from higher intensity to lower intensity, slope will keep on decreasing. And in case intensity is zero, that happens when uniformly varying load represented by triangle, if intensity is zero, slope also zero. Slope zero means what? It should be either like this or like this. Slope also should be zero. And where intensity is maximum, slope will be maximum. Sufficient. Now I will not talk about this one once again. If not clear, leave my class. My teaching is not suitable for you. You go for still better teachers. Okay, now, same way. Rate of change of BM is shear force. Therefore, if you want to see slope for BMD, see shear force diagram. If shear force decreases, BM slope also decreases. If shear force increases, BM slope also increases. If shear force is constant, then BM will be linear. Linear means slope is constant. Okay, now that's okay. That way you decide here. So you draw the curve so that you observe shearing force diagram. If the shearing force, I told you, for shear force slope, loading diagram. For BM slope, shear force diagram. If shear force increases, slope should increase. If shear force decreases, slope should decrease. And if shear force is zero, then slope for BMD, slope of BMD is also zero. And remember, that is the point where bending moment is either maximum or minimum. See, when the curve goes this way, where slope is zero, peak value, or see, sometimes it can come this way. Yes, where slope is zero, least value, generally maximum. But one thing, this question I am asking, these are all for beam when supported at both ends, or I will tell later. Now, later I am asking a question, I am uploading a class little later, brain teasers. There I will tell you one thing. See, I will put UDL here. I will tell shear force diagram is this way. BMD is like this. Okay, then this is the point where shear force is zero. That is the point where BM is maximum. This is the point where shear force maximum, BM also maximum. Then you should ask me, sir, you told earlier where shear force is zero, there BM is maximum. What happened suddenly here? Suddenly nothing happened. Pure mathematics. So all this principle, slope is valid here. That principle of BM maximum where shear force zero is not applicable for cantilever, but I will make it applicable. Someone will tell cantilever 100% not applicable. Suddenly I will make it applicable. Some will tell where this person came from. He tells something, then suddenly tells something else. Yes, that is called structural knowledge. So first, correct. So under a special case, even for cantilever also, I will show you where shear force zero, BM is maximum. Now, so therefore here, be careful. Actually, cantilever, there is no problem. So your worry is always when two side supports are there, propped cantilever, fixed beam, continuous beam, practically it comes. Or simply some overhang. Cantilever, anybody can draw it. But anyway, this I will ask in the brain teaser. One more thing is there. See, deflection is maximum where slope is zero. See, again brain teaser. See, this is the elastic curve. Where y is maximum,
slope dy by dx equal to 0. I will tell that in the class, deflection class. Then I will ask the question. For a cantilever, this is the elastic curve. Okay. Here, slope is maximum, deflection also maximum. Oh, what is this? Beautiful reason is there. Beautiful reason is there. I will not tell so easily. I will see that people struggle, including that sigma m0, sigma v0 also. People should struggle. They should tell finally, we are not able to solve. Then I will solve. Why? Sometimes you should get knowledge the harder way, not easy telling. Okay, take this way. Okay, start. Now, remember now, I am concluding now. UDL, shear force linear, BM second degree parabola. UVL, shear force second degree parabola, BM third degree parabola. Slope of the SFD is intensity of load. And slope of the BMD is shearing force. Okay. If load intensity reduces, slope of SFD also reduces. If load intensity increases, slope of SFD also increases. Where intensity is 0, slope is 0. BMD. If shear force decreases, slope will decrease. If shear force increases, slope will increase. Where shear force is 0, their bending moment is maximum. And one more thing, when you draw BMD, if the shear force diagram crosses the baseline this way, then see, shear force decreases, positive, then increases once again. So here, maximum shear force, maximum slope for BMD. Maximum shear force, maximum slope. Here 0. And this positive shear force, negative shear force, if the slope is anti-clockwise here, slope is clockwise here, opposite. Suppose you draw BMD this way, that is called BMD on tension side. Then if it is clockwise here, it is anti-clockwise here. Sufficient. What all I told just now, actually not to be told. Someone will tell, this person is telling same thing again and again. What to do? I have seen the people tell 100 times, still difficulty. 100 times, still difficulty. I know it. Okay, start. Now, start one by one. See, I will go, last time I told you simple case of one point load and also UDL, I think. Okay, now, I will go for more work. See, more type of curve. See, 1 minute now. UDL, last class I explained the UDL. If you remember. Yes or no? UDL, last class I explained for you. Okay, once again. See, take a simply supported beam subjected to UDL. Okay. Say W per unit length. Reaction is WL by 2. Remember, today's class I am not discussing what? I am not discussing how to find shear force, how to find bending moment, everything thoroughly over earlier. This class and if required next class, I am discussing variation. Okay, start. Now, A, B I will take here, span L. Shearing force diagram. See, here plus WL by 2. Left up is positive. Here minus WL by 2. Variation is linear, straight line. Over. Now see, slope of SFD here and slope of SFD here, slope of SFD, wherever you see is W. This I told you last time. Why? Constant. So no confusion. When you want join by linear, when you want not join by linear, when you want join using linear variation, straight line, anybody in the road will do it. Okay, now come to BMD. See, this is positive, negative. See, BM0 here, BM0 here BM is maximum. Parabola will come. Option comes. Is the parabola this way or is the parabola this way? See now. In case you draw by mistake parabola this way, see what happens now. Here, first of all, not possible. See here. Shear force maximum. Slope should be maximum here. As you go that way, shear force reduces, finally 0, then shear force again increases. So slope should change the direction. See, completely wrong. See here, if I draw this way, 0 slope here, see maximum slope. Not possible. Only possible is this way because, see here, maximum shear force, maximum slope. As you go here, shear force reduces, slope also reduces. Finally here, slope is 0. Then again slope will start increasing, but other direction. Again, maximum slope here. This everybody know it. But if somebody asks you, prove it means, they will tell, no, that's how in the college they are drawn, books they are drawn. But why that way? That I don't know. See, that I don't know. At least tell me, now I know it. Okay, now, come to uniformly varying load. I will do one thing. As I told, these classes, purpose is basic structural knowledge. It's what I am making public now is part of that one. So what I am covering now, my intention is to make fully clear for those who are in the group. But general public, they can understand. See, you take uniformly varying load, different types here. First, correctly understand. One case here. I hope one more case here, and if possible, one more case here. Okay. I will go for 4 cases now. Correctly systematic way exploration. See, uniformly varying load of this type. This is, I will put W by U. U means not W by U. W per unit length. There is a limit for me to explain. Board visible fully? 1 minute. Okay, board visible. Here also, see, W per unit length here. W per unit length, 0. Here I will do one thing. I will go this way. W per unit length. Correctly observe. Here, other way. All these 4 cases in the YouTube class in a single W per unit length at center. I am not writing. This is center, out of scale. Sometimes what happens is scale problem. If anybody comments, sir, that not look like center, you make it look like center. Don't comment unnecessary on these things. W per unit length. Okay, now see. Now, this is the backbone of SFD for BMD for UVL. See correctly. Now, I will enter the answer here. This is WL by 6. This is WL by 3. This is WL by 3. This is WL by 6. This is WL by 4. This is WL by 4. Some will tell, oh, sir, by hearted. Not by hearted. By looking only I can make out. W half into L by 2 into, half into W by 4. Not by hearting. I don't require by hearting. Okay. You am not, see, how this reaction came, that is not our concern. Our concern is variation. Now see, all the 4 cases, see now, A, B, A, B, A, B, A, B. Okay, now this is center C, L by 2, L by 2. Okay, this is L by 2, this is L by 2. In the YouTube class, all the 4 cases, bookwork and numerical are covered in a single class. I told complete UVL wash out in one class. Very thoroughly I made it. Class number I don't know, search it. Okay, now, one important, everywhere we want shearing force diagram. See, why left shearing force, how to calculate, that is what I tell now goes. If I tell shear force here is, if I tell here, for example, shear force here plus WL by 3, shear force here minus WL by 6. Somebody will ask, why? Why is not today's class? Earlier classes, class number 100 now. Earlier classes, go through it. This is the class meant for understanding variation. The difficulty of curve joining by curve. See, doubt comes. See, for example, it may come this way. This way or this way, doubt comes. That's what I am clarifying today. See, randomly I drawn. See now, start. For everything, see this line is shearing force diagram. I write here one place, full here, shearing force diagram, left up, right down, positive. I am not writing. I am not writing it. Little bit pop. Okay. See, still I told not writing, still I am writing. Left up, right down, positive. Nobody can ask me, what is this one? Class number 100. Okay, start. Now, See the shear force diagram. So first, see, shear, I will tell all the 4 cases, I will tell you shear force now. See, correctly what I am telling, if not clear, go to that class number earlier where compactly this is given. See, 1 minute, I have blocked the calls. Yes, yes. Suddenly remember, before each class, now do one thing, if possible remind me call blocking. Okay? So that in every class now onwards, when I start the class, not only here, in Zoom also, you usually remind me recording and charging, add one more, call blocking. Because why? If a call comes tilted, then again laptop problem will come. So just remind me always, one by one. You can tell all 3. You can tell all 3 sufficient. Okay? Just tell me all 3 so that I should not forget. All 3 means charging, then recording for Zoom, and YouTube or anywhere, not only YouTube, everywhere, call blocking. Okay. Now see, today onwards, no class in the nowhere you can see tilted images. Why? No call will come. Start. Now, I will tell the fast values now. If someone will tell he told something not properly explained, I have no answer because I told you what is today's class meant for. Shear force at A plus WL by 6, shear force at B minus WL by 3, shear force at A plus WL by 3, shear force at B minus WL by 6, shear force at A WL by 4, shear force at B also WL by 4, A positive, B negative, same there. And here, shear force here 0, shear force here 0, here shear force is 0, somewhere in between. Okay, where we will see later. Now start. Draw shearing force diagram. I told you how you can draw shear force diagram by a simple procedure. What you can do is, start. Now, go up by WL by 6. Sometime I have seen you go to online classes, YouTube, search SFD&BMD. My class also will come there. I have seen one person drawing SFD. I will tell you what a way to write it. See, he will tell this length is 10 meter. He got the reaction here something, not 10 meter, L only. He wrote shear force diagram. See, he told 6 here, 3 here. See, WL by 6 here, WL by 3 here. And he told here slope is 0, here slope is maximum. He drawn shear force diagram like this. Then he told this distance from here to here, he calculated, he got L by root 3, that is almost 1 divided by root 3 is 0.577 L. 0.577 L, or if the span is 10 meter, this distance is into 10. 5.7735 meter. Tell me, anybody will agree? If you write a diagram, you tell this is 5.7735. This is how much? This is how much? 5.7735. This is how much? This is only how much? How much it comes then? 4 point something. See, 4 point something. Will anybody will agree by looking at the diagram? This is 5. This is 4. Will anybody will agree? Tell me. How odd it will look. 5.577 is center, slightly right side. How much? From center, you have to go by only very minute right side. See, 5.7735 means from center go by 0.77 meter. Maybe if this is 10 meter, center is here. See, somewhere here. How it will look like? And so many times I have seen people drawing diagram. They will write here some values all. They will mark here this length. See, I'll tell you how diagram comes. Beautiful. Diagram comes this way. Then this length is 10 meter, not UL, some other case, 10 meter. They will calculate, write it as 7.85 meter. That is because of randomly marking coordinate. Will someone will tell 7.85 meter and remaining is how much? 2.15 meter, this much. This is 2.15 meter, this is 7 meter. Anybody in the road will agree? First of all, give me little, and for him give, tell me, I am not hungry, give me little. He is very hungry, give him bigger. See, For him, give huge food, huge amount. For me, little. Some sense required. So what you have to do is, this is first of all wrong because, see, 1 by 6, 1 by 3, you should know mathematically. If numerical is there, quite clear. 1 by 3 is a double of 1 by 6. Remember, if WL by 6 is 20, WL by 3 is 40, not 15. What comes to mind? 6 here, 3 here. No. Divide by 3, divide by 6. So, you should remember that what? This is double of this one. Here. This is double of that one. Here, both are equal. So, now, see. I will draw the diagram. Go up by, sometimes what people do is, they will randomly go here, WL by 6. Here, space problem. They will write WL by 3. Space problem. Then do one thing. If you are marking WL by 3 here, you mark only this much here. Or lift the diagram slightly. See, these are all called common senses. Okay, start. Now, go up by WL by 6. Okay, WL by 6. Suppose this is 10. Okay. From here to here, come down by half into L into W is WL by 2. 1 by 6 minus 1 by 2 is 1 by 3 negative. So here, WL by 3 below. This I cannot explain why. Already over earlier. WL by 6 means, see, WL by 6 here. 1 minute. I will make it more space problem here. See, this is WL by 6. Okay, some scale. 1, 2. Okay, now, okay, see, now reasonable. Not that you measure here correctly. Oh, 1 here. Not that way. Eyesight measurement. This is WL by how much? 3. Okay, come here. SFD here. Go up by WL by 3. Shift the diagram if you want more space. Go up by WL by 3. Come down by WL by 2. It will be WL by 6 here, half. This is WL by 6. Joining I will do later. Here. Go up by WL by 4. Here, after coming down fully, it will be once again same WL by 4 here. Here. Go up by WL by 4. Here also WL by 4. Okay. Now, joining. See, correctly, I will first join the SFD for all. I will explain thoroughly what I am telling, repeatedly go through and understand. In the YouTube class also I told this one, but not this way compact form. Our purpose is the concept here. Therefore, I will tell one thing now. UVL, 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 UVL. Now remember, there is a standard point in between here. Why? Here see, A to B, single variation. A to B, single variation. If I start the curve here, I should move the hand without stopping up to here. Here, if I start from A up to B, like a signature. See, you don't stop in a signature, correct? Suppose, see, I will put my signature. See, I put signature this way. I am not stopping. If you stop the signature, it will, in bank people, if you put a check, stop the signature, they will tell, sir, innonu bar sign madi. Sari illadu. Correct? So usually, majority, some rare cases, people put the name only signature. See, suppose their signature is bending. B, that is little illiterate. People usually has got their own signature. So signature, when you start the stroke, you end up to full. Single curve. See here, remember, make a note. A to B in between, no standard point. A to B in between, no standard point. But A to B in between, at center, there is a standard point. Why? Because load intensity keeps on increases. Once you reach C here, it decreases. So C is the point where intensity of load changes. Or A to C, minimum to maximum. C to B, maximum to minimum. Or from that side, minimum to maximum. So here, C also is a standard point. Therefore, when you draw SFD, right here, single stroke A to B. Single stroke A to B. Here, A to C, single stroke, stop. Then C to B, another stroke. here. A to C, single stroke, stop. Then C to B, another stroke. Tell me, fully clear or not? C to B, another stroke. If these four are clear, your major problem is taken care. Then I have to explain. Maybe one more class required for me. I will tell you when UDL comes here, UVL starts here. Those things I will tell. Will not take much time. And again, one more thing. As we go further, more and more diagram you are drawing. And in YouTube, all already explained. Now you go to YouTube previous classes. Correctly understand. Or your regular classes. This clear? First. Case 3 and case 4 repeat. Why? In case 3 and case 4, between A and B, there is another standard point. Yes or no? Answer first. Okay, no problem. Here, after A till B, no standard point. Like, take off a flight from Bangalore, land in where? Bombay. Take a flight from Bangalore, land in Delhi. Take a flight, like a flight journey. See, flight, once you take off, there is no in-between stop, correct? Recently, the local, our native place, one television channel is there, jokes. The person who is traveling in the flight, he told, I want food. He told, I want fish curry. The air hostess told, sorry sir, fish curry not available. Then he told what? Okay, no problem. In between, you stop somewhere in a restaurant side. I will go eat and come back. He was the first time going on flight. He told, actually he tells in Tulu language, Kannadadalli. Madhya nilsbudi, nanu tinkombartini anta. He told that way. Why ignorant? Once, suppose Bangalore to Delhi flight, single flight, how? Take off from Bangalore, directly land in Delhi. Clear? Here also. See, no standard point in between. Take off from Bangalore, land in Delhi. Here, not that way. Take off from Bangalore, maybe where in between? One station. Bangalore, Delhi in between. Any station is there? I don't remember. Flight. Okay. There is deviation. No straight one. Bangalore to in between. What is there? Madhya Pradesh, Indore, Hyderabad. Okay. From Bangalore, take off. Go to Hyderabad. Stop. Then more people will come. Again, take off from Hyderabad and go to Delhi. Clear now? Directly. Take off from Bangalore, land in Delhi. Take off from Bangalore, land in Delhi. Take off from Bangalore, reach Hyderabad. Again, take off there, go to Delhi. Why? C is a standard point. Why? Standard points are the extreme ends of the beam, or where point loads are there, or where couples are there, or where supports are there, or where UDL starts or UDL ends, or where intensity of UDL changes, or if UVL, where UVL starts, where UVL ends, or if varying in UVL, you may not get always triangle. If other type comes, where UVL intensity changes. Now clear? If the intensity changes, that also becomes standard point. Now clear? Yes. Therefore, remember, single stroke like signature, sign from A to B, flight from A to B, flight from A to B, flight from A to B, Allah, flight take off A, land at C, have coffee and come back. The way, that's what I am doing now. For non-stop talking. Little tea I will take. Coffee I stopped long back. Again take off, land at Delhi. Take off from Bangalore, land at Hyderabad. Take off from Hyderabad, land at Delhi. And one more thing I will tell you. See, intensity of load increases. Like, take off from, this is a new imagination. Remember, imagination. Some will tell, sir, this way journey is not there. Imagine, flight can take off, go up and up and up and up. Or flight can only come down and down like that. See, here, take off from Bangalore. Keep on going up and up and up, slowly, linearly up. When you reach Delhi, reach high point. Then, when you come near Delhi, stop. Then come down. Sir, how to come down this way? Just for fun I told. Or then, variation stops, come down. Here, in the Bangalore, take off to a high point. Then slowly start coming down. When you reach here, almost at the ground level. Here, take off from Bangalore, reach Hyderabad, reach a top point. Then stop there. How to stop there? Stop there. How means, okay, stop there. Gravity. Some special principle is there. Imagine like a helicopter. Okay, stop there. Then start once again. Then slowly start coming down. See here. In Bangalore only, go up high place. Slowly come down. Reach almost ground level. Okay, then again start going up. Clear fully? So, A to B single stroke, A to B single stroke, A to C one stroke, C to B one stroke, A to C one stroke, C to B one stroke. Stroke means like signature. You should stop the signature at C, then again continue. This one clear? This one clear or not? Nobody is commenting. Oh yes, okay, thank you. Now, I will do one thing now. Now remember all the 4 cases UVL. Tell the answer. You write all these 4 cases. All the 4 cases UVL. Therefore, tell the answer. SF variation. Fast. You have to tell SF variation. Tell the variation. All this we are discussing UVL. SF variation. All the 4 cases. UVL it is. Parabola of second degree. Parabola of second degree. Second degree. Okay. Now, when parabola of second degree is there, see, curve can be like this, curve can be like this. Here, it can be this way, or it can be, ayo, what is this one here? It can be this way, or this way. I don't know. We'll see later. See, when I draw wrong one, I got irritated. It can't be this way all. I will draw it. Okay, now, if you don't follow properly this one, sometimes what happens is your BMD will look like this. See, I have seen people drawing BMD. See. What is this one? Here, this side slope is more, that side slope is lesser. Because of space problem, they mark here some wrong. This is what? Some, what do you call, this way? That's all nonsense. That should not happen. When you draw something, if you know what you are drawing, that mistake will not come. Sometime I will tell. See, why I don't make mistake? Reason. One, simple reason. Some will tell, because sir, you have got experience. No. Not experience. When I tell something or when I write something, I know what I am telling or what I am writing. I know what I am telling, what I am writing. If I want to buy something in a shop on weight, I will tell kg. If I want to buy volume, I will tell liter. If I want to buy a cloth, I will tell meter. Or if I want to spend some time, rent something, I will tell hours. Why? I won't tell 1 kg hour I want scooter or give me 10 meter of rice. Why I will not tell that way? When you tell something, you should know what you are talking. If you know what you are talking, that major problem is gone. Sometimes people make mistake because they will not worry what they are telling. Suddenly, they will tell BM. Then tell, oh sorry, SF. How it is possible? They will tell SF equal to WL by 4 into L by 2. Then, oh, sorry. Sometimes comment will come there. Sir, it is not SF, sir, it is BM. Or when they tell BM, major mistake, they put kilonewton. How BM is in kilonewton? Someone will comment there. Sir, BM, not kilonewton. Oh, sorry. Confused. What confused? If he knows what he is writing, there will be no confusion. Okay, leave it. I want everybody who will learn from me to reach that level, if possible. My purpose is to make everybody to reach the level. Okay. Up above me, I am not telling. I will be very happy tomorrow if you tell, sir, how much your fluency is there. I have got same fluency. I will tell congratulations. But remember, I only taught you. Okay, now, this is fully clear, I think. Now see. Now second point is there. You told already, make a note. All the 4, it is parabola of second degree. So curvature. Now, curvature means doubt comes. See, whether curve is this way or this way, doubt comes. What to do is observe I already told you. I am not repeating. Some will tell, sir, this you are telling 100 times. To decide the type of curvature for shear force diagram, observe or look what? Observe or look what? Tell me. If you want to decide how is the curve, whether this way or this way, all see, you decide the curve always based on slope. Slope will tell you whether to go this way or whether to go this way. Make a note. How to decide the curve is finally based on slope. Inclination. Slope means what? Is the inclination this way or this way? So slope will tell you how to proceed. So if you want to decide the curvature, now onwards, I will not tell. Observe what? Tell me. Observe what? Observe what? I told 1,000 times. If you want to decide slope, see, to decide the type of curve, slope important. Slope will tell you everything. Observe what? Intensity of load, told 1,000 times. If you want to know the slope of SFD, see intensity of load. Later I will tell you, if you want to know the slope of BMD, observe shearing force diagram. Observe shearing force diagram. See, SF and BM, they are not simply WL by 2, WL square by WL by 4, WL square by 8, WL square by 12. They are actually crude method. Inside the mind, the feeling should come. If I look at a beam, I can see the bending. Even though beam is not bending, to the mind, it comes there to me. See, the mind, I can even see the bending moment. I can see the compression coming, tension coming there. I can even see the internal resisting force with the lever arm and balancing couple. How? Look there. Like I tell sometimes, good food is being prepared inside. You are very hungry and you are fond of the food. You can imagine from here only. It is visible to you. Or suppose you are in the outside your house. From inner mind, you can see your house. That way, feeling should come. Leave it now. So therefore, observe, yes. So therefore, to decide the slope of the shear force diagram, observe intensity of load. And I told you, intensity increases means slope increases. Intensity decreases means slope decreases. Intensity 0 means slope 0. Intensity maximum means slope maximum. If the intensity keeps on increasing, slope will keep on increasing. If intensity keeps on decreasing, slope will keep on decreasing. If intensity is what? 0, then slope also will be what? Slope also will be 0. These are clear. If intensity is 0, slope is 0. If intensity is maximum, slope also maximum. If intensity increases, slope also increases. If intensity decreases, slope also decreases. Tell me fast. Clear? Last comment required for me. You tell clear, sufficient. I will draw the diagram now. I will draw the diagram. Okay, now, see, I will tell you. A to B, I will tell first. A to B, intensity keeps on increases. And 0 intensity here, maximum intensity here. Okay, leave it. A to B, intensity keeps on decreases. Or from there, one side you do it. You can do from one side. Intensity keeps on decreases. And maximum intensity here, 0 intensity here. Come here. A to C, intensity keeps on what? Increases. And one more thing I forgot here. A0, here B0, here. A0 keeps on increasing, it keeps on increasing to get maximum here, then again decreases to get for 0 here. Maximum intensity at both ends here. When you come towards center, from either side, intensity keeps on decreasing, but we are drawing from one side. So what you do? A to C here, intensity increases, C maximum, then decreases, B0. A to C, intensity decreases, maximum at A, when you reach C, 0, again intensity increases, and maximum here. This should be clear. Now I will do one thing. I talk non-stop for more than 1 hour. I'll take a small break, but before the break, I will draw the SFD and go. Good. so that you need not waste time. You tell me comment box, is it crystal clear or not? I will explain later. Today I will finish BMD also. I will explain to you later. But see now, you should comment. Actually, I will be very, very happy if you tell what SFD you have drawn is fully clear for us. Every doubts are cleared. No doubts are there. How much perfection you are telling, not me. You are telling this way. How much perfection you have got. You means me. You should tell same perfection I also have got. I am a very happy person. See, I tease, rag. Ragging is not that ragging. And sometimes grind or force you to make the mistake or fool you. It is only for bringing you up, not for my personal enjoyment. I never enjoy by degrading others. Okay, start. I will draw now. See, slowly I will draw. I will do one thing. When I draw, I will mentally talk something. Okay, done. But I know the point, don't worry. Exact shape not required. Parabola. Okay, done. ಅಲ್ಲಿ ಎಷ್ಟು ಇಲ್ಲೂ ಅಷ್ಟೇ WL/4 ಜಾಗ ಸ್ಪೇಸ್ ಪ್ರಾಬ್ಲಮ್. This is wrong. See, that is actually wrong. Deliberately I had drawn. See, that is a deliberately I made mistake. ಸರಿಯಾ ಬರ ಅಯ್ಯೋ ಕೈ ಜಾರ್ತು ಅಯ್ಯೋ. Remember here single stroke, here one stroke and another stroke, or I'll do one thing, another stroke. See, this is one stroke, this is second stroke. This is one stroke. This is second stroke. You observe, I will take 5 minutes break because for non-stop talking. Then I will explain all this one and once for all clear for you the variation of SFD&BM, the curvature type. Then I will explain how BMD also comes here. Now sign required. Ayyo, adike plus minus. Sign is not a problem. You should comment now. If majority I get maximum comment, 100% clear, I'll be very happy person. I feel this much what I explained is really useful. Okay, 5 minutes. No trap today. I actually here when I draw, I was actually looking there. Then suddenly realized this case. No trap today. No, today no trap. I decided not to trap. Anyway, 5 minutes rest I want. Non-stop talking. Hope you don't mind. You should tell why you take the break. I am also a human being. At least little break required. I relax for 5 minutes and come back. Meanwhile, you observe everything what I had drawn. Full board you can see. Take a screenshot and correctly observe what all I told. Everything I told, you should comment now that crystal clear. Tell how much you know, that much we also know it. Okay, no problem. Just 5-6 minutes.
If I asked a question there, laptop problem is not there, everything is okay, because I'm still worried. I actually came to know what is the mistake. If the laptop problem is solved, I'll be very relieved person. Okay, because watching in the mobile is difficult to study students. Why? Because you can't hold this way and study. Laptop means you can put in the table, spread it, big screen comes, you can have a writing arrangement, you can relax and watch. So therefore, always remember, every class you should go through laptop only. So if there is no problem, I know the problem. What happened is that auto rotate, I used to activate earlier. Then I go for go live. No. It is asking, auto rotate, I will first type go live, then activate auto rotate. Yesterday, one class it happened other way, correctly came. See, in the RCC part, one side did correctly. Now, today I made a trial earlier, the second time. You should first activate auto rotate. That is, that auto rotate on. Then press go live. Then the screen will turn there. Then correctly it will come in the mobile, a laptop. So, problem solved is okay. Now the only problem is that lag. Again, you please do one thing. You encourage your friends, if you know anybody who is using live. Some apps are there. To go live, they will tell you use some apps. I do not want to use some random app and then nowadays you know it. It will ask permission. I do not want to give permission to some unknown apps. If you know somebody, reliable apps are there. Their lag will be 0. The moment I talk, you can see. You can hear, see, English problem. You can see in the display and hear in the ear. Okay. Now, see. Now, I will continue now. Voice clear? First. Voice clear. Voice is not a problem. Voice clear? Just a comment to make it more perfect. Actually, upper side, slight portion visible, I think. That I will remove tomorrow. Clear? Okay. See. Now draw shearing force diagram. See, what to do is, see here. Intensity 0. So, here, for the shearing force diagram, slope should be 0. Intensity maximum. Here, slope should be maximum. Slope is maximum. Here, intensity maximum. So, slope should be maximum. Intensity 0. Slope should be 0. Should be 0. Here, see. Intensity maximum. Sufficient. If I write everything. Okay. I'll tell you should write later. Intensity 0. Slope should be 0. Intensity maximum. Slope maximum. Intensity once again 0. Slope 0. 0. Okay, here. Intensity maximum. Slope maximum. Intensity 0. Slope 0. Intensity maximum. Slope maximum. But in between, one point is there. See, I will exaggerate this one now. This concept is clear? Tell me first. This concept clear? This concept clear or not? Okay, someone told clear. Now, therefore, when you start from here, see here, you go up by WL by 6. Curve can be either like this or like this. Suppose you draw curve like this. See now. Slope becomes maximum here. See, steep. Slowly become flat. No, not possible. Why? Because here your slope should be 0. If I draw a tangent here, 0, see, when you mark here, 0 slope means it should go this way. If you draw a tangent here, see, turning should be 0. Slowly, slope will increase. It will increase, maximum here. Single stroke here. See, here, slope is maximum 0. Here, see. Here, if I draw same way, it is wrong. Why? Suppose I draw same way, it is wrong because, see, intensity maximum. Here, 0 slope. No, wrong. See. So, here, maximum slope. And when you reach here, 0 slope. Okay, now, this should be clear. Here, see. Intensity 0. 0 slope.
maximum slope, see, it will come and turn. See here, maximum slope here. Again when you start, same maximum slope. Then slope will reduce, slope will become 0 here. See, this way. Here, intensity maximum, slope is maximum. Slowly, intensity reduces. So it will become flat, 0. Then again, from here, if I draw, see, actually, this side give exaggeration for you. It will be not that way. See, this point will be, see, this further. This way, not that way also. See, 1 minute. 0 slope, again 0 slope. See here, draw tangent for both 0 slope. Slope is 0. Okay, now flat. See, if I draw tangent here, not fully clear. YouTube class, I made more clear. Then, as you go that way, again intensity increases. See, steep. This is the correct principle of drawing shear force diagram, or how you decide the curve for shear force diagram. See, if UDL is there, no curvature. Shear force is linear. Be happy. So if UVL is there, follow this principle to decide the type of curve. Fully clear? Fully clear or not? Tell me. Fully clear or not? Fast I want. Yes. Now, I will tell one more thing for you. If someone asks me, can you draw this diagram without using that principle? You tell no. No, better not do it. I can draw. Why? Because I will tell that way. Shear force is WL/6. See, what I am telling now is not required for you. So, another 2 minutes, what I tell, you hear from this ear and leave from this ear unless it is clear. But remember, don't mix up. You stick to the principle I told just now. This extra principle, or what you can call is ultra ideas, don't go for it. It is not for you. Some will tell, what? You are the only one knowing. Okay, if you know, use it. Tomorrow you tell, sir, second thing what you told is confusing me. I will tell why you went for it. Leave it. Here, shear force WL/6. As I go this way, see now, don't worry, this is not for you. I am talking to myself only. I do not want that principle. As you go this way, intensity is lesser. Shear force will reduce gradually. As I go that way, shear force will reduce rapidly. Or if I start from here, shear force will reduce rapidly there. Reverse here. Here. From here to here, shear force will reduce gradually and rapidly as you go here. No, not required for you. If it is clear, tell me, I'll be happy. This is called ultra knowledge. These all you go once you reach perfection, not now. Once you reach that level, then try all these things. I told you, without seeing shear force diagram, I can decide the curve for bending moment diagram. How means I got better ideas. You show me any beam, shear force diagram, I will not ask. I will look and tell, curve this way, curve that way. Why? Why means this told me, my brain told me. That I will tell you also. But usually not that way. If you want slope for shear force diagram, see loading diagram. Now, next point is to locate the point where shear force is 0. I will not tell how to do it because out of scope of today, this will be L/√3 from here. That is little more than midpoint if you go this way. Here, from here L/√3. L/√3 is around 0.577 L. This is 0.577 L. Other is around how much? 0.4. Ayo, calculator problem. Too much depending on calculator. This is a problem. 1 divided by √3. Ayo, √3. Ayo, that is a problem. A calculator is not on. -1. 0.423. This will be around 0.423 L. This is here 0.423 L. How to remember? Don't remember left and right. This is separately done in the YouTube class. So there you have to do it. I told today's class is only variation. Now, how to locate? I think in your BSK class, trapezoidal loading, I told you how to locate. If you can, for your BSK batch, that is regular students batch, I thoroughly told you earlier. Okay. And others, go to my YouTube class 1 to 100. There, everything is told endless number of times. Today we are discussing only variation. Here, not worry, it is exactly midpoint. Not coming pen on. It is exactly midpoint. L by 2, L by 2. Out of scale. Okay. L by 2, L by 2. Okay. Now, draw bending moment diagram. Okay. 1 minute. See. Now, last part of today. This is not a confusion. Very simple. See now. Bending moment diagram. What you require for bending moment diagram is bending moment at all the standard points. And also bending moment where shear force is 0. Start. BM at A 0, BM at B 0, BM at A 0, BM at B 0, BM at A 0, BM at B 0, BM at C is WL square by, I forgot the number. Okay. W square by, I calculate. Okay, no problem. 1 by 4 into 0.2, 0.25 into 0.5 minus half into 0.5 into 1 into 1 by 3 of 0.5. Reciprocal. Some odd 0.25 into 0.5 minus half into 0.5 into 1 into 1 by 3 of 0.5. That is W square by 12. By 12. Here bending moment equal to 0.25 into 0.5 minus half into 0.5 into 1 into 2 by 3 of 0.5. Reciprocal. W square by 24. Some will tell, sir, when this is 1 by 12, it is half. No, separate sketches. Don't link the scale for these two. This is for same question. If some WS24 comes, if suppose some another WS24 comes, I should write half. Here separate sketch. Okay, these are the ordinates. So we got bending moment at the standard points A, B, 0, 0, A, B, 0, 0, A, B, C, 0, 0, W square by 12, A, B, 0, 0, C, W square by 24. Okay. You also require bending moment where shear force is 0. Start. Yes. This point you require bending moment. That is WL square by 9 root 3. Here I require bending moment. Yes. Exact scale I am not maintaining. Roughly I am writing W square by 9 root 3. Some will tell handwriting not good. You see not handwriting now. See the curvature. Handwriting is not required. Here already over. Shear force 0 here already known. See here shear force 0 at a standard point over. Now join. I told you 1000 times earlier to decide and all the 4 cases UVL. So SFD SF variation, not SFD variation, SF variation. Sometimes people tell calculation of SFD and BMD. No, it is not calculation of SFD BMD. Calculation of SFBM, drawing SFD BMD. Some will tell BMD at BC. What is BMD at C? BM at C. Give respect to subject. Okay, now. Shear force variation slope you get from intensity. BM variation, UVL, parabola of third degree. Right, remember all the 4 cases, third degree parabola, cubic curve. And I told earlier, to decide the curve, you need slope. Slope of SFD is intensity of load. Same way, lastly comment, slope of BMD is, I want your comment. Slope of BMD is, I want the comment. Slope of BMD is, oh, time already over. I should finish fast. SF, not SFD, sorry. SF, not SFD. SF. Who told SFD? Nandakumar. No. Don't tell SFD. SF. Right. SF. Start here. Maximum SF here reduces to 0 and again increases. Other side. One side plus, one side minus. See, curve. This way will come. Remember now, here the slope is WL by 6. Here the slope is more. See here, WL by 3. lesser slope here, but maximum this side. WL by 6 slope here. Slope reduces, shear force reduces. Finally, here slope is 0. Then again slope become other way. When you reach here, again maximum slope, WL by 3. This slope is double of this slope. Here, see. Again, see here. Here slope is more, there slope is lesser, here 0. Okay. 0 slope here, see maximum slope here, WL by 3, reduces 0, then other side, opposite way, again slope increases, here slope is WL by 6, here. Slope 0, shear force maximum here, both are equal, and 0 here, see. This way, this slope is WL by 4, this slope also WL by 4, 0 slope here, same here also. Now see here, slope maximum positive keeps on reducing 0. See now, if I draw by mistake this way, how nonsense it is. Why? 0 slope here and maximum slope here. No. Shear force maximum, slope maximum. Shear force reduces, slope reduces. Shear force 0, 0 slope. Now, I think this is sufficient, I think. Yes or no? Like SFD, not required because all the 4 common. If fully clear, tell me. Time already over. If tomorrow I will explain to you, lastly, uniformly varying load represented by a trapezium. There, see, the 0 slope will not come. Minimum slope to maximum slope. Once I explain that one, I will take tomorrow some more cases and then suddenly start, continue the chapter, shearing force and bending moment diagram. I will continue systematically, first for couples and then overhanging beams. So many principles are there, then cantilever. If fully clear, tell me, so that no point in explaining same thing again and again. Correct? All the 4 BMD same. Only thing is what? Here maximum at center, here maximum, not center, slightly shifted that side where intensity is more. That is around 7%. 8%? 0.57, sorry. Around 7% more length from center, it will shift to that side. Thank you. Fully clear. I will close the class and tomorrow I will explain this type of this one and then some diagram I will write for you. UDL one side, UVL other side, how the transition will take place and common mistake people make. I will highlight that one. Tomorrow you can close it. Next day I will start a series of SFD&BMD for couples. Warning for those who are newcomers. I told lot of principle in the where? In the YouTube classes. Go through it. And BSK batch, I told much more. So you should know it. BSK batch, my regular batch, no problem. By this time, you should be expert. So when I go for bending moment, you should not ask tomorrow, sir, why it is plus, why it is minus. I will tell, leave the class. If a sign convention problem comes, why plus, why minus, if confusion, I will tell, leave the class. Okay, thank you. I will close now. Hope this laptop problem solved now. Now only lag problem. Those who are knowing, you can inquire with your friends and let me know solution for lag. If that problem solved, everything is perfect. I think now you will agree, YouTube class is better than Zoom class. Yes or no? Surely, YouTube class, display, voice, etc. much better than Zoom class. Compare the voice. There cut will come. Here no cut, nothing. Crystal clear voice. Okay, thank you. But red color not visible. Okay, I will change the color sheet. One thing I forgotten. One thing I forgotten. Next time remember, there is, when I go live, there is an option there, go to normal mode. I find it, I forget it. That normal mode, if I press, natural color will come. See, again forgotten today. There is a normal mode is there. It is default is something else. One normal mode, I forget that one today. Everything I remember, but even then, little red you can make out there. Remind me to press the normal mode. A normal mode where color will be as it, a coloring mode is there. There, one normal if I press, Color comes as it is. Remind me next time. Tell me normal mode. Okay. Just remind me normal mode. Okay, thank you. I will close the class now. Close.